Now that we are studying digital electronics, you may very well ask, what is digital electronics? Digital, as opposed to analog, refers essentially to a rounded quantity. For example, if 4 asked Phi what is the temperature right now, Phi might reply minus 16.245 degrees Celsius. This approaches an analog measurement. For most practical purposes, it is sufficient to say minus 16 degrees. This is a digital quantity. In digital electronics, we push this practical idea to its logical conclusion. The answer to any query can be only one of two things, true or false. Each response is called a logic state. Because there are only two logic states, we call this binary logic. This means that the queries themselves must be statements that can either be true or false. This indeed makes it easy to encode each response for the purpose of transmission. Thus, you could toss a white marble for true and a red marble for false. Each coded true or false is called a binary digit or bit. We would need to make a sequence of true-false queries to get the information we need. Behold the future of romance. This sequence of bits forms a digital signal. For storage, bits are packaged in groups of fixed length called bytes. In digital electronics, we use electric pulses to encode and transmit data. Typically, a high voltage pulse is used to encode true, a low voltage pulse to encode false. The data is therefore transmitted in the form of an electric digital signal. Now, why go through all this just to plan a dinner date? Well, communication is a tricky business. During transmission, signals are subject to decay over space and time, and to noise from other sources. With a digital signal, however, it is possible to reconstruct the original responses with a high degree of fidelity. This, therefore, is the main advantage of using digital coding.